This is example 3 in section 9.2. We are continuing what we learned about yesterday. Number 1 is a fourth root. So instead of groups of 2 or groups of 3, we are looking at groups of 4. Whatever your index is, that's how you're trying to split up these factors. So we have x to the 7th. How many groups of 4 are in 7? 1 group of 4. Visually, some of you really like the visual of this. So here's one full group of 4. They get to break out and become a normal x outside. And these 3 are still stuck inside the radical. So we have the fourth root of x to the 3rd. And that would be our final answer. The long way to do this would be to split this into the fourth root of x to the 4th, fourth root of x to the 3rd. This becomes the x, and the fourth root of x to the 3 stays under the radical. Do you want another one like that with a fourth root, or do you feel like you're good? Good? Okay. Number 2 looks like it's the most complicated that we have. Before you start doing anything, I want you to look at everything that you have in here. Remember, if we can split square roots up using division, we can also combine square roots using division. So 60p to the 11th is on the top. We have 5 on the bottom. Think about the fraction 60 divided by 5. Can we do 60 divided by 5? What is 60 divided by 5? 12. So we have 12p to the 11th. Doesn't that seem a lot simpler than what we originally started with? So now we can split this into the square root of 12 and the square root of p to the 11th. Square root of 12. What perfect squares can we split 12 into? 4 and 3. The square root of 4 is 2. So we have 2 times the square root of 3. Now let's think about p to the 11th. How many groups of 2 are there in 11? 5. That'd be 10 of them. And then there would be 1 of them left over. Put this in our final answer, the stuff not under the radical, 2p to the 5th. And then the stuff, excuse me, under the radical, 3p. Okay, so for p to the 11th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 1, 2, 3, 4, 5 full groups. That's where the p to the 5th comes from. No, go back. And then this 1 left over, that is the one that's still under the radical. I would like you to try number 3 on your own. Square root of 80, x to the 30th. Remember, you split it into the square root of 80. Simplify that. Square root of x to the 30th. When we think about the square root of 80, there's a lot of possibilities. There's 4 times 20. But when 4 works, there's a chance that something bigger might work, like maybe 16?
Yeah, 16.
If 4 works, try 16, because they often, especially if you've got a number as big as 80. If 4 works, try 16. The square root of 16 is 4, so we have 4 times the square root of 5. For the square root of x to the 30th, this is one where I'm really not going to draw out 30 dots. How many groups of 2 are there in 30?
I need the visual. 15.
15. Okay, then I'll draw the dots just for you. Do you really want me to draw the dots?
Yes.
Okay. Because as soon as I said that, I was like, I don't really want to. Or remember from the other day, this is the same as x to the 30 divided by 2, which is x to the 15th. All right, our final answer. 4x to the 15th times the square root of 5. Your assignment today is the 9.2 worksheet, which I will hand out now. Under 5 minutes. Woohoo!